Hello everyone, today we are going to do lecture number 13, practice problems, properties of gas and its units. Like in this chapter, we're gonna describe the properties of the gas and we're gonna use those properties in the word problems. Like as you can see in the question number 1, there is a list the properties of the gas and their SI system units. So we have like 4 properties of gas and they have like their SI units. Like in pressure we have atm, pa, millimeter of mercury, and torr. These are the units we gonna use in the pressure, for the pressure. And for the temperature it's Kelvin, degree Celsius, or the Celsius. And for the volume it's liters, milliliters, centimeter cube, and meter cube. And for the moles it's like moles and mole. So for the second question, it's on a climb up Mount Whitney, the atmospheric pressure drops to 467 milliliter mercury. What is the pressure in terms of atm and torr? So already we have given like 467 milliliters of mercury, and now we're gonna find out like what is the pressure in terms of atm and torr. If the atmospheric pressure is this, what is the pressure in terms of atm and torr? And we have given like pressure in this. We're gonna find out the pressure in atm and in torr. So for this, we already know that 1 atm is equal to 760 of this. So 467 of this given, and we're gonna divide it. Like 467 over 760 equals to this much atm pressure is over there. And now we know that so they just want to know that in atm, so we already described this. So understanding the conditions of the Boyle's law, what 2 properties of gas are considered in Boyle's law? So which 2 properties we use in the gas law? That is pressure and volume. And what properties of gas must be constant for us to use Boyle's law? Pressure and temperature and volume. So what is the formula for the Boyle's law? It's P1 V1 equals to P2 V2. And we have to understand the concepts of Boyle's law. For that, why does a sealed bag of chips expand when you take it to the higher altitude? In complete sentence, explain using your knowledge, the kinetic molecular theory. So as we know that P1 V1, pressure volume equals to pressure over volume. So pressure to whatever is given, like P1 V1 is equal to P2 V2. So elevation pressure increases from outside. Whenever we goes to the higher altitudes, our pressure increases. So other word problem is the pressure of 5.0 liters of gas increases from 1.50 atm to 1240 millimeters of mercury. So what is the final volume of in liters of the gas, assuming the constant temperature? P1 V1 equals to P2 V. So now we already knew that there is pressure given, and sorry, there is volume given because here is the liters, so volumes given, pressure is given, and there is the other pressure given like in other units, but this is also pressure. So we're gonna find out the volume. We're gonna find out V2. So now according to our question, this is obvious that we're gonna use Boyle's law. So according to Boyle's law, as we already knew, that P1 V1 equal to P2 V2. So we're gonna use this formula and we're gonna plug in the values. Like as we know that V1 equals to 5.0 liters, and we know that P1 equals to 1.50 atm, and we know that P2 equals to 1240 Hg mercury. So we're gonna find out V2, and we know the formula, so we just gonna plug in the values. So according when we're gonna plug in the values, like 5.0 liter into 1.50 atm over 12.40, then we 1240, sorry, and we're gonna get whatever okay, there is one more thing, that we're gonna change this into atm, and to change this into atm we have to multiply this with 760, because 1 atm is equal to this 760. So we're gonna get this value and we're gonna plug in here and multiply all of the things, and then we're gonna get 4.5 liter of the volume 2. So it's 4.5 liter. There is other problem that what's the Charles law actually? What two properties of the gas are considered as the Charles law? And this is what we know. V is inversely proportional to the P. V is volume inversely proportional to the pressure. What is the property the most constant as used as a Charles law and predict the behavior of the gas? At constant P, volume increases and temperature also increases. Volume increases when the P is constant, volume increases, temperature also increases when P is constant. So formula for the Charles law is temperature T1 over V1 equals to T2 over V2. So there is a problem related to this Charles law. A fixed amount of gas at 25 degrees Celsius occupies a volume 10.0 liters when the pressure is 629 torr. Calculate the volume of the gas. So when temperature increases. So first of all, we have to change this Celsius into Kelvins. For that we have to add into 273 plus 121 equals to um, so we're gonna get 395. 395, gonna get this value 395, and then for here you're gonna add 273 in 25, and you're gonna get 295. So we have to use like this formula. This is the Charles law formula, and we have to plug in according to this. But actually here we have to use like time, pressure, and volume too. So we are not going to use this. We are going to use this formula, P1 V1 over T1, P2 V2 over T2, because we have T1, we have V1, we have P1, we have T2. So we need to find out the pressure. So here, like, we have to plug in all the values here, and you're gonna get 1.2 liters. And then there is one more question, that is the air in a 5.00 liter tank has pressure this and volume this. What is the final pressure in the atmosphere when the air placed in the tank is volume this, V2, if there is no change in the properties of the gas? So if there is no change in the properties of the gas, so gas law, there is P, we are gonna use this formula, P1 V1 equal to P2 V2. So whatever values we have for P1 is 800 torr and V1 is 5.00 liters, you're gonna plug in that, and then there is other thing we have to know, change, because if we have this here in liters and here is in mils, so we're gonna change it into liters. For that we're gonna divide it in this 1 liter by 1000 mils to get our value, and then once we're gonna get the value, we gonna plug in whole formula here and get the answer.